All right, we're going to be looking at doing an indirect proof. Now, from yesterday's assignment and the day before that lecture, we know that if an original statement is true, then the contrapositive will be true. Same thing, if you can prove the contrapositive true, then that means the original will be true. So these are called logically equivalent. So we can come up with another type of proof, meaning we're proving the contrapositive. And that means the original must be true. So with an indirect proof, we start by assuming the opposite of what we want to prove, which is the conclusion of our original statement. We start by assuming the opposite of the conclusion. And then we show that that leads to the opposite of what is given, or we call it a contradiction to the given. Which is our hypothesis, contradicts the hypothesis. Now, in the indirect proof, we start by assume, and we actually use this phraseology, assume temporarily. We use those exact words every single time we do an indirect proof. Assume temporarily the opposite of what we want to prove. Which is the conclusion. Make this other piece smaller so it gets out of our way. We then use that assumption and logical reasoning with the theorems we have, the definitions we have, the postulates or properties, to arrive at the contradiction of the given or some other known fact. So we then use this assumption and logical reasoning as well as theorems and postulates and properties definitions. And sometimes even part of the given to arrive at a contradiction to either the other part of the given or some well-known fact, such as if you come up with the angle sum of a triangle being something rather than 180, right? Then that would be something that would be a false statement. Okay, so we sometimes will use part of the given to arrive at a contradiction of either the given or some other known property. The next phraseology that is always used is in the conclusion of an indirect proof. We always start with assume temporarily the opposite of what we want to prove, which is the conclusion. We always end with this contradicts. Use those exact words. This contradicts. And then we state what it contradicts, whether it be the given information, blah, 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 or whether it be if we come up with the angle sum other than 180, this contradicts the fact that the angle sum of a triangle is 180 degrees, that type of thing. So this contradicts, which means the opposite must be true. Fill in the blank. And instead, fill in the blank. That's a blank spot you're going to fill in. And instead, another blank spot must be true. So if I erase this other quotation mark, I could put a blank spot. This contradicts on whatever information. So the opposite of what we assumed, fill in your assumption there, must be true, and instead, what you want to prove must be true. And in quotation, this is just about exactly what your last sentence, which is the conclusion of your proof, will be. So what's going to go in these blank spots? This contradicts, and here you put, how can I show this? Maybe in a parenthesis, underlined, or I don't know. I have a different color, so for me, fact or given goes here. Yep, this contradicts whatever it contradicts, some type of fact or the given information. Whatever that information is goes in that blank spot. So the opposite of what we assumed and what will go in this blank spot is this part right here, what you want to prove or the conclusion of your statement, right? So the opposite of what we assumed, and here you put what you assumed. Goes right there. Must be true, and instead, this right here is what you want to prove. Yes, Francis.
What's the last word?
Be true. Be true. So you always start the indirect proof the same, and you always end the indirect proofs the same. Using these pretty much exact words, filling in the specific information in the part that we have green. For some reason it's going very slow. I'm trying to have patience. Maybe didn't have enough. Okay. I got it. So we're going to try indirect proof here. My indirect proofs are going to be very much like some of the proofs you are going to do. Why is my computer going so slow? What is it doing to this? Pause there too, and it might not have done that, but I think it's going now. Let's continue. All right, so the first indirect proof is example 1 on page 214. We are given that n is an integer and n squared is even. What we want to prove is that n is also even. And that looks like an m. Let me try to get an n there. When we do an indirect proof, what are the words we start with? Assume temporarily. These right here are the words that we always start with. So we're going to assume temporarily what? What do we assume temporarily? The opposite of the conclusion, or the opposite of what we want to prove. What is the conclusion or what we want to prove this time?
N is even.
N is even. So we're going to start with assume temporarily. What is the opposite of n is even? N isn't even, which means n is
Odd.
odd. So we're going to assume temporarily. Now, we're at the middle piece now. We're going to use this assumption and logical reasoning to arrive at a contradiction. What does a contradiction mean? Branson, what is a contradiction? Do you ever contradict your parents?
Yes.
What does a contradiction mean?
Argue.
Yeah, they say something, you say something exactly the opposite. I do contradict you. You also contradict me. Exactly. Okay, that's a contradiction.
Back to that argument.
Exactly, yes. So now, we want to arrive at a contradiction of the given. We want to come up with an opposite statement to that n squared is even. We're going to go with, keep that n as an integer, but we're going to contradict that n squared is even using this information. So, if n is odd, what happens if we go n times n, which is n squared? What happens if we go odd number times odd number? We're using logical reasoning. You get an odd number, you do. So, if n is odd, then n times n, which is n squared, will be odd times odd. If we multiply an odd number times an odd number, what will we always get? An odd number, because you already told me that. But why? How do we get an even number when we multiply? We have to have a factor of 2 in order to, when we multiply, get an even number. The only way you can have a factor of 2 is to be no. So now, what we will end up with is n squared then will equal an odd number. Okay, now we have a contradiction to the given information. So we go to this conclusion statement. We're always going to use this last statement as a conclusion. Our conclusion statement says this contradicts, and in this case, we're contradicting the given information that n squared is even. This contradicts
There you go. That's magic. You think it,
Okay, so we have stated this first part of that. This contradicts the given that n squared is even. Now we go with, so the opposite of what we assumed. So the opposite of what we assumed that n is odd goes there, must be true, and instead n is even goes there. This is supposed to be n is odd. I know that my writing kind of slid together. I'm not seeing what I'm writing is one reason. Okay? So the opposite of, quotes, n is odd must be true. And instead, n is an even number. Here we end our proof with that nice little box paragraph, because it is a type of paragraph proof. So starting number 6 on the assignment on page 216, we're going to assume temporarily the opposite of what we want to prove. We're going to assume temporarily that it is warm outside, we decided was the opposite of it is cold. So now we use logical reasoning. We're doing that middle part of this proof. If it is warm outside, and we can look at part of the given. Part of the given is people are wearing coats.
So it's gonna be.
So, no. If it's warm outside and people are wearing coats, what's going to be happening?
Sweat.
They're going to be sweaty. Yes, they're going to be hot.
Everybody in town was really, really bad, so they were
Now, people are hot and sweaty. Is this a contradiction to another part of the given? Do we have a contradiction to another part of the given? Yeah, because it says they're shivering. So now we're starting this last sentence, which is the conclusion.
Please, teachers at this time, the Mr. Thomas, Mr. Thomas, appreciate it. There you go.
The given information that people are shivering. Now we go to the next piece, which is so the opposite of what we assumed, that it is warm outside. Must be true. And then we finish off with the last part of this, which is, and instead, and then we put, it must be cold. Is, instead, it must be cold outside.
Take this home to the office.
End of paragraph proof.